Official day counter. Math 335, lecture day 6. We're finishing up a little in R7 or R6. And doing R7 and hopefully R9. So let's prep, not R9, 9.1. So let's do a little bit of prep for some stuff we're gonna do today. So in R6, what we need to finish is radical equations. We're gonna go over a simpler one first, just to get it in your head. Square root of 3x minus 2 equals 5.
You want to square both sides?
That's what we want to do. So just like if we said 2 equals 2 and then I squared both sides, I'd have 4 equals 4. Equality is maintained is the big thing. It's kept. So that's what we're going to do here because it clears the radical. So raise it to the power that clears the radical. So the left side will be 3x minus 2. And the right side is 25. Then we solve. By 3 and we get x equals 9. It's worth noting that by doing this, we may have introduced answers that don't work. So what that means is check your work. In the original. You gotta do it in the original, no matter how fucking lame it is. And when I say lame, it may be really lame. You may have a fraction that you gotta plug in. And you're like, this fucking sucks.
No.
But that's where you gotta check it, because you may have done a mistake going from step 1 or from the starting line to step 1. So we are gonna plug this into the very initial equation. I had 3x minus 2 in the square roots. I'm gonna have 3 times 9 minus 2 in the square roots now. Does that equal 5? What's 3 times 9?
27. 5. 24. Oh, yeah.
Square root of 25 does equal 5. Notice you should, especially if you're doing this where you're sharing it with others, you should show it's a check. The question mark suffices. Because you're saying, I don't know if they're equal, I'm checking if they are. Sometimes they're not equal, and so you don't want to start off saying they're equal, and all of a sudden you end up with 7 equals 5. And then you say, well, no, it didn't equal, so. Here we're saying we think it equals. Look at another one. Square root of 2x plus 1 equals -3. Why don't you guys try to do what we did on that last problem, do that here? Then we'll do it together. There's a lot of teenagers on campus, and I'm wondering how many of them are here just so that they don't have to be in class.
I think it's like a tour.
I know, but if you don't like attending class and there's a tour somewhere, field trips get you out of class.
Well, on the other side, I can't just say that there's 20 kids in groups just moving around. Half of them aren't even paying attention, but they won't get out of the sidewalk, so they had to walk on like the grass or like the bark. And I was like, really, you guys have to do over?
It's surprising the percentage of the population that's just flat out fucking oblivious and doesn't give a fuck. Oblivious or doesn't give a fuck.
Yeah.
Phones said like our modern phones had not helped.
Hmm.
In the last 10 years, it's fun watching videos of people that are fucking texting and, you know, walk into some shit or fall off a fucking. Something that doesn't hurt them.
A long time ago, I had one of those, old, the ones with the pin on them. I was driving in the call and it like jammed, right? I don't know, I had like ketchup or something on it previously and I tried to, and then boom, like, I catch.
Oh. And then others will just see you coming. Be standing or in wherever they are, right in the middle of the fucking way. Make eye contact with you, cause then you know they fucking saw you, they're not oblivious. And then just not fucking move. See it happen a lot in crosswalks too, or jaywalking. People walking and it almost looks like they fucking slow down a hair. Like a power play, but you don't have the fucking power. If I'm driving a vehicle, you're only not injured because I chose to not fucking accelerate and hit you. Cause I can get away with it sometimes and there wouldn't be anyone to fucking give a report. You know? They're jaywalking, so it's not at an intersection, there's no cameras nearby.
I don't know, like, yeah, you could, this sounds country, I know if you go into like different cities, they have like cameras everywhere.
I'm not gonna hit and run, but I could, that's the point.
But if you were going.
When you slow down and you're like, I don't give a fuck if you're driving, I'm walking. And you're gonna fucking brake and stop. Which is harder to do in a moving vehicle than it is for a pedestrian.
Mhm.
It's also a waste of fuel.
Or momentum.
Yeah, every time you brake, you're losing energy.
Yeah.
Alright, did you guys do it?
Yes.
What'd you guys get?
Green, wait, what did?
What's the final answer? I heard -2.
Too.
Did you get that? What'd you get? She might not be right. What'd you get?
I think I messed up.
What'd you get?
I got,
What'd you get?
I got 3, I messed up.
Well, don't assume you messed up. I don't know what it is.
Four.
I have no idea what it is. Let's do it. I love that we all have different answers. This is exciting.
It's not.
Right, now you're no longer even money to be right. So we square it. And what do I get?
9.
And on the left,
Oh, I just went your side.
We should do the right hand side. Right. And subtract 1 from 9. Positive 8. Divide 2 by both sides. And we're left with x equals 4.
Sarah's looking pretty good right now.
What?
You said 3, right?
Yes.
But is she right? Why not, Sarah?
Because it would be square root of 9 and it's -3, so it's wrong.
That's right. Does the square root of 9 equal -3? No. So there is no solution to this problem. This is actually something you could have identified at the beginning. But it's not always the case. Sometimes the problem has like 2 solutions and you'll. This isn't always the case, but we could have identified it before we started. We had square root of 2x plus 1 equals -3. What if I just said, treated that as a fucking like question mark? Question mark. What has the square root? When you take the square root, you get -3. Nothing. Square roots only produce positive numbers. So it doesn't matter if there's any negative number on the other side. And the radical is all by itself already. Then you're fucked. Make sense?
Yes.
It's not something you always think to check. But you might. But you should always check your work. Alright. So we'll do some more of that today in class. That was fun, right?
Yes.
R7 has some weird factoring. Factoring unusual shit. Maybe we should say advanced factoring. That sounds more professional. Seems like that's a big concern of mine, right? Sound professional.
Yeah.
I'd rather be effective than professional. There's a lot of very professional math teachers that students don't want to fuck with us to. At least try to make it fun. Alright, so let's factor this.
X, right? That is common.
So we're gonna, there's 4 terms.
Yes.
So when we were looking at the factoring 4 terms, we had to do it by grouping.
Yes.
So we're gonna group up these 2 and these 2. This actually doesn't have anything in common, but maybe when we factor this one, we'll see it. So what we do here is we pull out the term with the lowest exponent. And I mean lowest, not closest to zero. But lowest. You might be wondering how that's fucking different. You'll see. So the term that's got the lowest exponent is x squared. So if I pull out an x squared, I can see what I have left if I just divide this by x squared. So I'm just gonna do the first part real quick. And I'm doing it slower than we did before because it's gonna lead into like how you can do the factoring of the hard shit. Well, that's x squared, and then you can split it up, you can do it over each. And we saw that we subtracted exponents when there was division.
Yes.
Slow way of getting to x minus 1 on the inside. Because x to the 0 equals 1. And we're doing the whole x to the n over x to the n equals x to the m minus n. Then we want to see if that x minus 1 repeats. It does. The right side has an x minus 1. So the factor that must go out front is just a plus 1.
Okay. Looks like a better method. Because usually they just kind of like pull like the beginning part, except without bringing to a fraction, and then they start doing fractions.
Normally, you wouldn't do the fraction.
Yeah.
You would skip this fraction shit. I'm showing the fraction shit for a reason.
Yeah.
The harder shit isn't intuitive.
Oh yeah.
It follows the exact same process though.
Yeah.
So if you see why this works here, then it might be easier when I start doing fucking negative numbers and fractions and shit like that.
So at the ending though, you.
At the ending, we got this in both groups.
Where does you get the positive one? It's supposed to be one positive.
Because if I want to put it in a group, I gotta have something multiplied by it. I don't want to just say plus this,
Oh.
because the idea is to factor this out.
Right.
There's an x minus 1 there. And that leaves behind an x squared plus 1.
Okay.
Okay? If I factor out the x minus 1, how I did that is I had x minus 1 and I factored out x minus 1. So when they cancel out, you're left with 1. Is everyone okay with that? That's kind of like what we've done before.
Yes.
Alright, where it gets fun is when we switch to harder shit. Same premise. Factor out the term with the lowest exponent. What's the lowest exponent here?
Negative 3 x is negative 2.
That is not the lowest. Would you rather owe me $2 or would you rather owe me $4?
2.
2, why? Because it's a little bit higher, you get to keep a little bit more. -4 is lower than -2.
Oh,
So x to the negative fourth is lowest term. We are going to factor out a negative 4. And this is a 4 and this is a 3, so nothing, none of the coefficients factor. And we can see that if we do the dividing by x to the negative 4, what we should have left over. And that's why I showed this in the last step, because this is an intuitive to what to do when you pull x to the negative 4, what's left. So I have 4 x to the negative 4 minus negative 4 plus 3 x to the negative 2 minus negative 4 minus 12. This is really x to the 0 minus negative 4. Does that make sense so far? This is, see how this isn't as intuitive?
Yes.
So we have x to the negative 4. Negative 4 minus a negative is plus. This ends up being 4x to the 0. Negative 2 minus negative 4 is negative 2 plus 4 is 2. And 0 minus negative 4 is positive 4. So this is negative 12x to the 4th. You can keep them in that order if you want. You shouldn't leave the x to 0 though. Or you can put them in descending order.
Yeah.
That's actually it.
Oh, that's it? Finals?
It might factor, I don't think so though. If it does factor, we would want to go further. We would need something that multiplies the negative 48 and adds to 3. There's 8 and negative 6, that adds to 2. 4 and 12 is 8, and that's the next combination. There isn't anything that adds to 3.
Oh,
Does that make sense?
yeah.
I'm gonna give you guys one. Factor that completely. Give everyone a chance to finish and start seeing who got what, and then we'll do it together. What should we factor out before we get started? Make sure everyone's factoring out the right thing.
-6.
Close,
2.
2x to the -6. 2 divides into each of these numbers as well. Look at me being tricky. That's some sneaky shit. So if you didn't do 2x to the -6, try doing 2x to the -6. Guess how many people are enrolled in this section right now? Because there's 3 of you in here. That's how many are actually enrolled.
1, 3.
I count 3 of you.
Oh,
How many are actually enrolled in the class then?
20.
Oh, that's way too high.
Oh,
God, that would be a fucking even more abysmal attendance rate than it is. 8.
8.
Less than half the people are here.
You like math?
The point is, that if you took this class, it was. You should probably be benefiting from the support, the extra practice. I know one of them's sick though. They emailed me. Anyone got an answer for what's left after we factor out 2x minus 6?
Yeah. And
What'd you get?
I got 12x plus 6x squared plus x.
That?
Yes.
Well, these would add together, right?
Yes.
So that would be like 13x. Right? Anyone else get that? What'd you get, Lauren or Sarah?
I got 2x to the -6. Minus 12x to the 4th. Plus 6x to the 2nd plus 1.
Okay. Did anyone else get that? Lauren, what'd you get? Did you get something or did you finish it?
I didn't finish it, I got, x plus 6x to the 2nd. Plus 12x to the 4th.
So it's close. The only thing you're different on is the 1 versus the X.
I didn't know if it turned into one or if it turned into an X.
Let's find out. Let's do it together. So we have 2x to the -6. Plus 12x to the -4 plus 24x to the -2, and we're gonna factor out the 2x to the -6. Kind of what we're doing here is what we're doing is effectively multiplying this by 2x to the -6 over 2x to the -6, which is 1, right? This is 1, but then we take this and we move this shit inside. So that's why we are able to do what we do. We have the 2x minus 6 here. I'm gonna put them over each other separately. Because the coefficients change things up a little bit. All right, so what happens with the first one when we cancel everything out? The 2's cancel. I can either cancel x to the -6 and x to the -6 are the same. Or I can do -6 minus -6. Which would be x to the 0. Which is 1. Here, 12 divided by 2 is 2 or 6. And then we have -4 minus -6. -4 plus 6 effectively is 2, so 6x squared. And then we do -2 minus -6. And we get, I'm missing a 2 there. And if you rearrange the order, you will get what Sarah got.
So you can't factor it in further, that's why
No,
I chose X instead of 1, because I thought you factored,
there's no factors of 12 that add to 6.
um,
But you can always check. But in this case, no. All right, and then that's kind of stuff we're gonna do in R7. Let's take a look at 9.1. 9.1, chapter 9 is on functions, and this is looking at graphing linear equations. Or equations. Let's not do linear. Hello? This is Mr. Jones. What can I help you with? Okay. Okay. So there was part of the roof got blown off and it looked like it hit the cables. The electricity in the kitchen got screwed up. There was the smell of like burning plastic basically. And now the kitchen lights are flickering. Like brown, like kind of like it would in a brownout, but it's only in the kitchen, so there's electrical damage. So part of the roof blew off. That's going on inside the house, and then a section of the fence in the backyard blew down. It doesn't look like a branch fell on them. It looks like the roof hit the lines, but it might have been a branch. We don't know what happened. No, one is coming on Saturday. I wanted to check with claims before I did anything. They're coming on Saturday to give us an estimate only. That's what the guy that called me earlier said. Right. Okay. It happened during the storm. It'd be oddly coincidental if it was anything but that. Not that I know of. No, they haven't. Okay. Okay. Thank you. Bye. Sorry about that, guys. My mom's house had, it's in Sacramento, and storm fucked up the house. And our first time ever using homeowners insurance, and I'm like, if I can call claims people, don't know what's going on. And so like, don't fucking call at any time. Graphing equations. This might actually only be on linear equations. Yeah, 9.1 is on linear equations. So it's only lines. 3x plus 6y equals 9. That is a linear equation in 2 variables. So one way is making a table. And common values to do are -1, 0, and 1. You kind of want to do 3 points. It only takes 2 points to make a line. But the third point will make sure like it's a line that you didn't fucking choose wrong. Because if one of them the points was wrong, then they're not gonna line up when you graph them. So if I stick in -1 for x, I solve for y. Add 3 to both sides, I get 6y equals 12, y equals 2. So that's x equals -1. If I do x equals 0, 3 times 0 plus 6y equals 9 is just 6y equals 9. So y equals 9/6, which is 3/2 or 1.5. And finally, if I stick in 1, I have 6y plus 3 equals 9. So 6y equals 6, and y equals 1. Everyone ready to graph it? So I got. That's my chart there. When we graph, make a vertical axis and horizontal axis. This is called the y-axis. That's the x-axis. And if you're using graph paper, it's a little bit easier. If you're not, you kind of want to do little hash marks to show stuff. I tend to make every fifth one larger. It's kind of a little bit easier to see what's what when you're looking at it. As you go to the right on X, you get positive numbers. When you go left on X, you get negative numbers. So positive over here, negative over here. And Y is positive above the center and negative below the center. So this is positive 5 and negative 5. And then we tend to write pairs as X comma Y, which is called an X comma Y is an ordered pair. And it's also known as coordinates. So my points here were -1, 2, 0, 1.5, and 1, 1. The first number is how far left or right we go. And the second number is how far up and down we go from the center. So the center is 0, 0. X equals 0 there and Y equals 0 there. So our first point, -1, 2. Left 1, up 2. -1, 2. The second one is left or right 0, so we don't move left or right. And we go up 1.5. So we're right there, and that's 0, 1.5. And 1, 1, we go right 1 and up 1, which puts us right there. Y'all with me?
Yeah.
All right. Notice if I line them up, they're all on one. That's why we do 3 points. If they're all on the same line, then they're probably accurate. If you made a mistake and they don't all lie on the same line, something's wrong. You gotta go back and check your points. So that's how we graph the line. That's by just plotting points. All right, next piece of information. Where it crosses this vertical line is called the y-intercept, which is actually one of the points we did. The other spot where it crosses the other line is called the x-intercept, or where it intercepts the x-axis. I will frequently abbreviate them as X int and Y int. Fucking fly. That fly was not bothering me until the fucking phone rang,
It was over here just a little while ago.
was it? So along the y-intercept, that was the 0.0, 1.5. Anywhere it crosses this line right here has a different y value, but the thing that stays constant along this line is the x value. The y-intercept has an x value equal to 0. And y equals, we don't know, call it b. The x-intercept has a different x value for everything on this line. But what remains the same is it doesn't go up or down. So the y value equals 0. So we're gonna have a y value equals 0 on the x-intercept axis, or on the x-intercept. Which means we don't know what x is, we're gonna say x equals a. Fucking annoying. So this ends up being A0 and 0B. Maybe I should do a capital B because my lowercase b looks like a 6. Maybe I'll do a capital A because my lowercase a looks like a 9. All right, so we have, what was the equation we had here?
3x plus 6y equals 9.
Yep, that's what we got. So we can, it looks like from this picture, it looks like that should be 4, 0. But I'm not going to assume that's correct because maybe I'm not using graph paper, I'm drawing it by hand. That may not be right. It looks like 4, 0, but don't assume shit like that. You can always just check it by plugging in the criteria. So for the x-intercept, y equals 0. That's true for any x-intercept. So I will plug in y equals 0 here. I get 3x plus 6 times 0 equals 9. So 3x equals 9, thank you. And x equals 3. It looks like this should have been the 0.30. So bad drawing on my part. Should be 30. Just found that out. And for the y-intercept, we do x equals 0. So 3 times 0 plus 6y equals 9. So 6y equals 9. And y equals 9 over 6, which is 3/2, which is 1.5. So that is the y-intercept. And that is the x-intercept. It's an ordered pair. It's wrong to say the x-intercept is 3. All right, that looks like we got a pause.
Well now.